All right, so we're recording the class and we're looking at chapter 8 and net present value and IRR. And I'm just going to go down here to the bottom where there's nothing. So this isn't on your sheet. Okay. So eventually you should see just a blank white screen. Okay. And what I'm interested in is essentially analyzing some idea. Now imagine if you had this. Imagine if I said, hey, I've got this idea where I'm going to spend $100 today, and 1 year from now, I should get back $115. So this is what I'm spending today, and this is what I'm going to get back in 1 year. Now the question is it a good idea to spend $100 to get back $115 a year later? Yeah. So let's go to the, all right, how about Kylie? You there, Kylie?
Yeah.
All right, so spending $100 to get back 115, is that a good idea?
It would be, yeah.
Why, yes?
Because if you're spending 100 to get back, sorry, losing my voice. If you're spending 100 to get back more than you're spending, you'd be getting more. Yeah, wouldn't you be getting?
You're making money.
$15.
Yeah. So you can kind of see what she said is, hey, this looks like a good idea because it looks like I'm getting back more than I'm spending. In fact, you can put this on a percentage basis. Okay. Now, here's one of the other things. What if the money wasn't free? Yeah. So everything comes at a limit at some point in time. Yeah. One, the $115, if you knew for sure you were going to get it back, okay, you knew with 100% certainty that 115 was the exact number. So there wasn't any risk or very minimal amount of risk. Then if you borrowed $100, yeah, as long as the appropriate interest rate associated with that $100. Okay, now you say, well, what's the appropriate interest rate? Well, remember, if you didn't spend that $100, and let's assume that this 115 is risk-free, that you know with high certainty that you'll get the 115 back. But it doesn't mean that you're actually going to make, I mean, it does mean you're going to make 15%. Yeah, we could figure that out pretty easily. But remember, if you didn't spend the $100 on this project, you could spend it somewhere else. Yeah. In other words, there's an opportunity cost of utilizing that $100. And in fact, the very least, you could sit it in a bank account and maybe earn 2%. So if in fact the opportunity cost of using the money somewhere else is 2%, then it's worthwhile and you're better off. Okay. You could also look at this. What if you didn't have the $100? What if I didn't have the $100, but I had to borrow it? Well, if you didn't have $100 and you had to borrow it, and suppose you could borrow it at 8%, then you can see that you're still better off, because if you borrowed it at 8%, then you'd pay back 108 and you'd still have 115 coming in, which is more than enough to pay it off. Okay. Now, you can kind of see the point at which taking on this project would not be good. Okay. it's kind of hard for us to see because the interest rate seems so high. But what if you couldn't obtain credit very easily? And in fact, you had to borrow money at 20% interest. If you had to borrow money at 20% interest, then this is what you have to pay back. And all of a sudden now getting 115 a year from now isn't really that attractive because you had to borrow the money at 20%. So a lot of times we ask these questions, is something a good idea or not? It kind of depends. And what does it depend on? It depends on your circumstances. Okay. So if we go back and look at it, if we look at the idea that you spend $100 today to get back 115, well, what happens if this 115 is sort of an estimate of what we expect to get back? When in reality, the 115 could vary widely depending on circumstances. Okay. So what if the 115 is what we call the expected value, but we recognize that there's a lot of variation between the outcomes? Okay. Then what happens? Now all of a sudden, this idea of spending 100 to get back 115, well, 115 is only one of any possible number of outcomes. If things go really well and the economy is strong, maybe we get back $120. Or if things go south, maybe we get back 110. Okay. Or if we have something dramatic happen, maybe we get back $80. Or something unbelievably good happens, maybe we get back 140. Most things in business follow this. What's this? This is an outcome that we have to analyze, but it depends or varies with lots of factors that are beyond our control. Okay. So the idea, if you just started a business, 6 months ago, it's sort of hard to foresee the economic situation we're in right now, which is everyone at home, pandemic going across the world. It's kind of hard to imagine that 6 months ago. But most people in business will at least have some sort of probability of some unexpected event occurring. Now, the unexpected event can be negative or positive. So it kind of depends on your outlook. I mean, imagine the guy that started this Zoom teleconferencing. He used to work for Cisco, I think, and said, I think I'll start one and give it away for free. I mean, he had like 20 million, now he's got like 200 million people on Zoom. Okay. I imagine that outcome would have been over here from his perspective. Okay. Or, on the downside, 6 months ago, you started a business and the business was some bar or restaurant and now no one can go there. Yeah. Well, that's the downside. Yeah. So how do we then incorporate this risk? Well, let me just show you something. I'm going to have to stop sharing here for a second. Give me just a second to pull it up. All right, what I'm going to show you now is what's called a binomial distribution. All right. And this is how we look at probability distributions. All right, let me go back. Abby there?
Yes, I'm here.
All right, Abby. If I were to throw up 100 pennies, or you can, doesn't matter. You can throw up the 100 pennies. If you throw up 100 pennies, how many heads or tails do you expect to happen?
Probably 50.
50. Everyone's going to say 50. Okay, not everyone, but almost everyone. Okay. When you throw up 100 coins, I say, hey, how many tails do you expect to get? People say 50. Okay. Because there's a 50-50 chance of heads coming up and a 50-50 chance of tails coming up. But if a whole bunch of people did it, let's say the whole class did it, we all throw them up. We should have done this. Okay. Throw them up and count them. Okay. Everyone gets 100 pennies, throw them up in the air, count how many tails you get. Okay. If we had 100 people doing this, okay, I would expect that only 8 out of those 100 people would actually get 50 tails. Okay. That means there's only an 8% chance of getting 50, exactly 50 tails, even though that's what we expect will happen. Okay. Now, what are some other likely outcomes? Now, it is the most likely outcome, and it's the most probable outcome. Okay. But getting 50 tails, having that occur when you throw up 100 coins only occurs about 8% of the time. What are some other likely things to occur? Someone will get 49 and 51. Someone will get 51, 49. Someone will get 48, 47, 46, 45. Okay. Someone else might get 55 tails, 56 tails. Okay. And we can actually see how likely this is to occur. And this is a normal distribution. Is it possible to get no tails? All heads come up. Yes, it's possible. But we don't really talk about that actually happening. Why not? Well, you throw up 100 coins, the probability of getting all oops, I'm not even there yet. The probability of getting there we go. The probability of getting all heads is whatever this is, 0.0000000. So if you throw up 100 coins, is it possible they'll all land on heads and you'll have no tails? Yes, but that probability is like 1 in 25 quadrillion. I don't even know what the number is. Okay, we can put it in it's 7.89 times e to the negative 31. Okay, so whatever quadrillion that is, it's essentially 0. Okay, now as you move up, you'll notice I've hidden a few of these things. This is the far end of the extreme distribution. Okay, if we focus on what's more likely to happen, okay, what's more likely to happen? Well, somewhere between 45 to 46, 47, 48, 49, 50, 51, 52, 53, 54, 55. Somewhere around there is what's more likely to happen. So actually what you should have said Abby, although it would sound weird, but it's technically correct. You should have said, hey, or if I ask you, what's the probability of getting 50 tails to come up? Or excuse me, if I threw up 100 coins, how many do you expect to happen? How many tails do you expect to get? The answer is actually something like this: 50 with a standard deviation of 5. Okay? And the standard deviation of 5 tells you how confident you are in your answer. Okay? And what we typically know from a standard deviation is what? Plus or minus 1 standard deviation around the mean. Oh, no, that's picking up. How about now? Plus or minus 1 standard deviation around the mean. So if I throw up 100 coins and I said, hey, how many tails do you expect to get? And you say, well, 50, but with the standard deviation of 5, that will actually cover about 68% of the outcomes. Okay? So that means somewhere in this range is where it's more likely to occur. The larger the standard deviation, the more flat out the curve is, and the greater the risk. Okay? So we need to take in, when we talk about things, both risk and return. In this case, if we looked at this problem where we spend $100 to get back 115, is it a good deal? It's a good deal as long as the appropriate interest rate is less than the return that this project earns. Okay. So if this was a risk-free security and the risk-free rate was, say, 2%, then this project is absolutely good. Okay. But if this is a risky project, and while we expect to get 115 back, that's the most likely outcome, but there's a whole bunch of variation in the actual outcomes that can occur, and it could be as high as 130 or maybe as low as 100. Okay, if we have a lot of variation in this, then maybe the appropriate interest rate is 12%, at which point the project is still good. Or we go to even a riskier scenario where the expected return is 115, but we could see things like $70 or $160. Okay. And maybe the appropriate interest rate here is 22%, in which case the project would be bad. You wouldn't want to spend $100 if you needed to earn 22 on a project that only gives you 115. Okay. So the same project can be good or bad depending on circumstances. It can be good or bad depending on the variables that you input into it. So your model's only as good as your data. And what we can see is the decision making that you have is only as good as the information you put into it. Okay. Now let's go back and look at chapter 8. Okay. Now, here's the thing that we're going to need to do. We need to figure out what is net present value. Okay. Now, normally I would have had you do some multiple choice type stuff, and I may still give it to you. I just haven't. I'm a little behind. Once I catch up, maybe I'll do it. probably give you some multiple choice things to do for this chapter. Okay. I'm hoping to put them into a quiz type format where you actually go in and do it, and then I'll grade it. But I haven't figured out how to do the points the way I want it to. But anyway, plus I haven't had time. But at some point, you need to read through the chapter and look at what exactly is net present value. Okay? And what net present value is it's one of the tools that we use to evaluate a project. And you'll see why we need to use it, okay, after we go through this problem. So here we've got an idea that's expected to produce $30,000 in cash flow in year 1, $40,000 in year 2, and $50,000 in year 3. Now, the project costs up front $100,000. So now we've got to evaluate whether or not this project is a good idea. What we're going to need before we can evaluate is something called a relevant discount rate. What's the relevant discount rate? I mean, that's something that you're inputting in, okay, in real life. For this class, it's given, okay? But in real life, you're wanting to figure out how certain are you that this 30,000 in cash flow will occur? How certain are you the 40,000 will occur? How much variation is around there? Is this project a government contract for 3 years to produce some kind of medicine? Okay. Or is this something like Beanie Babies? Yeah. Or is this something like a consumer product fad? Yeah. Or is it something that may stick around? Yeah. That's for you to decide. Okay. And how much variation there is between your best guess and what really happens determines what the relevant discount rate is. Now, like I said, we have 3 chapters to figure all this stuff out. This right here will give you a little more insight in the later chapter. Okay. This right here, how do I know how much cash a project will produce? This is found in a later chapter. Okay. And we'll get to them. Okay. We just break down this idea of capital budgeting is not just one chapter. Capital budgeting is like 4 chapters. Okay. We break down each of the different components. So if you're saying, hey, where'd the 30,000 come from? Don't worry. We'll find it in a later chapter. How do we know whether the 6% is good? I know it's given, later chapter. Okay. So for now, what's this chapter? This chapter is focusing on the tools we can use to answer the questions. Okay. The inputs will be figured out in a later chapter. Okay. So now we've got to decide whether or not this project should be accepted or not. Okay. It sounds good. We're getting back, at least we're getting back more than we put up. Okay. But we need to evaluate not only this project, but we need to evaluate this compared to others. And so we'll have something called mutually exclusive projects. So we're going to need to evaluate a bunch of projects at the same time. So we need something that standardizes our decision making. Now, most people would say, well, why don't you just evaluate it at the end and see if you make more money than it costs? Good idea. Okay. Doesn't work so well with mutually exclusive projects because we might have one project that lasts 3 years and another project that lasts 5. So we're not going to evaluate the projects whether or not they make money by looking at the end. We're going to instead look at it relative to the beginning. So guess what we get to do? What was the answer to every question in this class? Present value of future cash flows. So what we're going to do is find the present value of future cash flows and compare it to the initial investment. Okay? And if the present value of future cash flows is greater than the initial investment, then the project is good. Okay? And in fact, if this is true, something called NPV, or net present value, will be positive. So good projects have positive net present values. This project is good because it has a positive net present value. If it has a positive net present value, it means if you were to evaluate it at the end of its life, you'll have made more money than it costs, even after accounting for the interest rate. So the nature of time value of money is such that we can move cash flows around anywhere we want. Most people like to evaluate things after they're all done. That is, hey, let's see if this worked out. I invest in something, or I buy something today, and a few years later I sell it, and I see if I made any money. With projects and capital budgeting, you could do that, but because of the fact that we want to compare mutually exclusive projects, we're actually going to do the opposite. And instead of comparing it at the end, because one project might last 2 years, another 3, another 5, we instead do it at the beginning, which gives you the same answer. It just gives it to you in a little bit different format. Okay? So let's go ahead and look. I'll show you the hard way for one problem, and then we'll go back and do the easy way. All right. Talia, you there?
Yes.
Okay. Let's look at finding the present value of the future cash flow. So I'm still in 1A, okay? And what I have is $30,000 is the cash flow from year 1. And I want to figure out what it's worth today at 6% interest. How do I figure that out?
Would you still use like putting the 30,000 as the PV?
Now the 30,000 is in year 1. So I'm trying to figure out, that's at the end of 1 year. I want to figure out what it's worth today.
You add the interest to it?
Now the 30,000, it sort of looks, can you see my screen? It's going to look
Yes.
like this. 30,000 is coming in year 1. What's the present value today? At 6% interest. This goes back to chapter 4. The 30,000 is not the present value. The 30,000 is what?
The future value?
Yes. The 6% is the interest rate. How many periods are there?
Oh, 1.
Okay, what's the payment?
I'm not sure.
0. There is no payment. In chapter 4, we never had any payments. So single period cash flow. So what would the present value be?
Am I supposed to say it? Because I saw you wrote it on the screen, but
Go ahead. Did you get it?
20, yes, 28,302.
Very good. So you can either use your financial calculator or you can go old school and do it by hand. Okay. So that's the present value of the year 1 cash flow. I'm going to go ahead and erase this. Now let's look at the year 2 cash flow. The year 2 cash flow is $40,000. It comes 2 years from now. And I want to find the present value of the 40,000 2 years from now. Derek, you there? What about that one?
Yeah, the present value of that would be 35,600.
Okay. You can either do it by hand or put in future value. N equals 2, I is still 6. Oops. No payment, find the present value. Yeah. All right, now what about the $50,000 3 years from now? I'm gonna go ahead and erase it. So I found the 30, the 40. Now I need to find the 50. Blake, you there?
Yeah, I'm here.
Oh, Blake Moore, sorry. Other Blake.
Yeah, I'm here.
Okay, what about the 50,000 3 years from now?
41,981.
Okay. All right, now let's add all these together. I can do that. 41,981 plus 35,600 plus 28,302. Add all these up. I get 105,883. So basically what it's saying is the present value of the future cash flow, this is in fact, it's a cost, what net present value is and what your decision making is a cost benefit analysis, okay? And guess what? This is the present value of the benefits. Okay. So this project at 6% interest is basically worth 105,883 today. Even though it's $120,000, it's spread out over 3 years. So it's worth about 105,883 at 6%. So if I've got a project that has a benefit to me of $105,883 and only costs $100,000, then that project is good because it will have a positive net present value. Now, how do I calculate that? The present value of the benefits minus the upfront cost. It has a net benefit of $5,883. Hey, what's the net present value of the project at 6%? Should it be accepted? Yes. The net benefit or net present value is $5,883, and it should be accepted. All right. Some of you are thinking, hey, can't we do this a lot easier because you showed me how to use NPV in my calculator? Yes, of course. Yeah. Now, I don't know where my book is. If you look somewhere in the back of your book, now I already showed a lot of you this, yeah, but if you look in the back of your book on page 630, where is it? 632. It's in Appendix D. Page 632, but only if you have the HP 10B or the BA 2+ calculator. Okay. Page 632 will give you a refresher of how to find the net present value. Using your financial calculator. And it has to do with entering in the cash flows. So you've got to clear everything out. Okay. And then basically what I showed you earlier is that you're going to have to put the cash flows in. So for me, I've got the 10A, the BA 2+. So I need to clear all my work out. All right. And then I'm going to enter in 100,000. Use my plus minus key to make it negative and hit enter. Okay. Then I'm going to use the down arrow key. And I'm going to type in 30,000 and hit enter. Then my down arrow key, leave it at 1. That's how many times it repeats. Use my down arrow key again to get cash flow 2, which is 40,000. Hit enter. Use my down arrow key. F2 is 1. Just leave it at that. Or this says hit enter and then the down arrow key. Cash flow 3 is 50,000. Hit enter. And then I'm going to go and do the NPV. And it says, what is I equal to? I is equal to 6. Enter. Down arrow key. NPV equals 0. I'll hit compute. And I get $5,883. Yeah. Now, knowing how to use your calculator is good, okay? Because like I said before, certain tests that you have to take will require you only to use a calculator. Now, what's the advantage of being at home? You can use your phone app to find NPV. Yeah. Or what we'll see is that if you have Excel, which we do, if you have Excel, I'm going to show it to you in just a second. then look how easy it will be to calculate in Excel. Okay. We'll go ahead and put time up here. 0, 1, 2, 3. Here's my cash flows. Negative 100,000, 30,000, 40,000, and 50,000. Now, if I want to calculate net present value, for instance, I'm going to go into the function into a cell below and type in equals NPV. Then it's going to ask for the rate. In Excel, the rate will be a decimal, I believe, 0.06, followed by a comma. Then it's going to want the values. Okay, value 1, value 2, value 3. Okay, this is where it's kind of tricky. Okay, net present value in Excel only calculates the net present value of the benefits, or calculates the present value of the benefits. Okay? So when you're using Excel, you have to be very, very careful. NPV is a little bit different than in your calculator. Okay? And NPV is a little bit different than the definition. Okay? So what NPV stands for in Excel is the present value of the benefits. Okay. Now, knowing the present value of the benefits, what happened? Knowing the present value of the benefits is good. Because then you can subtract out the upfront cost. The upfront costs were just 100,000. And if you want to find the net present value or net benefits, just add the two together. A lot of people, when they do a net present value calculation, they'll write it like this, equals NPV. They'll type in the rate. They'll put in the 3 cash flows. And then after you close the parentheses, they'll add the upfront cost. Okay. So you'll often see, if you look up here, net present value written as equals NPV with parentheses for the function. And then after you close the parentheses, they'll just add back in the year 0 cash flow. So you can see that that turns out to be pretty good. Okay. We can see that in this case, the net present value is positive. But that was at 6%. If you look back at the question, I think it says something along the lines of, what is the net present value of the project if the discount rate is 10%? All right, so if we looked at this, and this was the net present value at 6%. And we wanted to evaluate the net present value at 10%. We could go back and do it by hand, just like we did before. Or we could go in and change up our functions. And we can see that at 6%, the project was good. But at 10%, the benefits didn't exceed the costs. Now, this is kind of weird. As interest rates change or as economic situations change, okay, then the interest rate associated with projects can change. Okay, so we can see, hey, at 6% it was good, at 10% it was bad. I wonder what the break-even point would be. Now, what's interesting is the break-even point is something called the internal rate of return. The break-even point is known as the IRR. And if 6% meant the project's good and 10% meant the project is bad, then at some point there must be some discount rate that makes the present value of the benefits equal to the upfront costs. And if we're solving for that, we could go in and solve it by trial and error. We could go back in and use our calculator and find the internal rate of return, or we can use Excel. And we type in equals IRR. And here you're typing in for your cash flows. I just highlighted from V2 to E3. You do all of them. Close the parentheses. And I can see here that at about 8.9%, the project would break even. So what does this mean? This means in order to solve the problems, IRR, we're going to need a financial calculator or Excel. In Excel, it's real easy. Just type in equals IRR and calculate. And so the internal rate of return basically says, as long as the appropriate rate of return is less than 8.9%, the NPV will be positive and the project will be a good one. All right. Let me stop here. Any questions on internal rate of return or NPV?
Oh, on the financial calculator,
Yes.
whenever you go into the current cash flows,
What kind of calculator do you have?
VA2 plus.
Oh, okay. Yep.
So whenever you go into the cash flows, there's a CF0. and then
That's
you go
negative
down,
100,000. Yep.
Right. But then after the first, second, and third cash flows, there's always an F, like F0. And
Well, there won't be an F0, but there'll be an F1. After the first cash flow, there'll be an F1.
Correct.
That's how many times that repeats. So if you had something where it repeated for 10 years instead of putting it in 10 times, if it repeated in year 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you wouldn't have to put in all 10 years if it was the same cash flow. You could, that F button is how many times it repeats.
Okay, thank you.
Most of the time, I just leave it at 1 because I don't have problems that repeat a lot. And if you did, you know, why would you need a financial calculator? You probably use Excel. You know, if you're trying to find like something on, let's say it was some kind of complicated problem where you had 40 years of data and the first 10 years were one number the next 10 years were another number, the next 10 years were another number, the next 10 years were a different number. You wouldn't have to put it in 40 times because they each repeated. You would just put F equals 10 for each of those cash flows. You probably won't see that. That's why I just sort of just leave it at 1. Okay. But if you have something super complicated, it's better to use Excel. But I guess if you're on a desert island or somewhere, it might be easier to do it that way. All right, so we've got one more thing to look at. So we're looking at NPV and IRR, and we're going to have a few more tools. NPV and IRR are the best. That's what everyone uses. Okay. You know NPV and IRR, you know a lot of information. Occasionally, though, some people, for simplicity and because it's hard to explain to other employees what NPV and IRR is, sometimes companies will implement like a payback rule. They say, hey, I want an idea, but the idea has to pay for itself in, say, less than 2 years. Okay. So they want people to use a payback period because it's easy. It's not really that useful. It can be misleading. And if you were a financial person, you probably wouldn't want to use it. But if you're a non-financial person, it would make a lot of sense to you. Okay. And we can actually evaluate or use this tool to help us sort of see things maybe in a little bit different light. Okay. What is the payback period? It's real easy. How long until the project recovers the upfront cost? So the project has to recover the upfront cost in some period of time. And how long does it take before it does it? Now notice it has some negatives to it. It ignores the time value of money, but it makes things simple that you could explain it to someone else rather easily, hopefully. In other words, this project gets paid back in 2.6 years. Now, how did I get the 2.6? Well, I spent 100,000. I got back 30 in year 1. So I'm part of the way there. I got back 40 in year 2. So now I'm like 70% of the way there. Then I get back 50 in year 3, which is 120,000. I've more than paid back the 100,000. So assuming the 50 doesn't come as a lump sum, even if it came in on a monthly basis, of say, I don't know what that would be, $4,000 something a month. I don't know what it is, 4,250 maybe, I don't know. Anyway, it came in at 4,000 something a month. How long would it take before it's fully recovered? So we're going to go to start out. This is called the year before full recovery.
Oh, Mr. Dow,
Yeah.
your screen isn't sharing. All I see is a picture.
Sorry. Thank you. Forgot about that. All right. So what is the payback period? It's how long until the project recovers the upfront costs. So in this case, somewhere between year 2 and year 3. So if we had 100,000, we got back 30 in year 1 and 40 in year 2. That's $70,000. But in year 3, we got back more than the 30,000 we were short. So you go to the year before full recovery, that's year 2, plus how much we need to fully recover. divided by the amount we receive in year 3. All right. So in this case, it's somewhere between year 2 and year 3 is when the payback period occurs. It occurs at around 2.6 years because I've got 70,000 after 2 years. So that's where the 2 comes from. I need 30,000 to get full recovery, and I'm getting 50,000 in year 3. So it turns out to be 2.6 years. So this project would have a payback of about 2.6 years. Okay. Again, this is not really one that's used a lot, except when you're dealing with people who aren't really financially competent. Okay. So if you wanted to say, hey, I got 50 employees, I don't want to teach them NPV and IRR. So I tell them, hey, you guys come up with a project, but it needs to pay for itself within 2 years. Yeah. You figure, hey, if the project can pay for itself within 2 years, it's probably going to be a good one. Yeah. So it gives someone kind of a benchmark. Yeah. Now, what we can glean from this is that shorter payback periods, okay, projects that have a shorter payback period, okay, are usually more liquid, okay, and can have less risk. Why is that? It's because things are hard to predict farther into the future. If you've got a project that pays for itself pretty quickly, you can have some bad things happen, okay? And as long as it doesn't happen in a short period of time, you're better off. Yeah. So you can you can kind of get it if someone said, I got this idea. Yeah, we're going to need to put up a whole bunch of money, and in 15 years we get our money back. Yeah. Well, that's a little bit more risky than someone saying, hey, I got a project, we put the money up today and we get paid back within 9 months. Okay. As long as everything goes well for 9 months, we get our money back. And everything after that adds to our profitability. Okay. Now, obviously, in real life, everything's a balance. And people say, well, don't be so short-sighted. You know, sometimes it takes a long-term investment to come up with something that's truly worthwhile. And some things have long payback periods, okay, but are very valuable. All right. Now that we've got the basics, okay, and now that we've got Excel and our calculators, or some people really like to use the app on their phone to find NPV and IRR. Yeah. Because it gives you the little places to put the cash flows. I don't care what you use. Okay. Obviously, to me, you're going to have to be able to find the number, but the number is going to be less important than the interpretation. Okay. So I'm going to ask you questions later. You'll see later on. I'll have you find numbers, but with technology, finding the numbers is pretty easy. Okay. What's harder is interpreting what they mean and being able to explain what they mean. All right, let's look at number 2. Consider 2 mutually exclusive projects, Project A and Project B. All right. Project A costs $250,000 and lasts for 4 years. Now, how do we know a project's only going to last for 4 years? Yeah. Well, I mean, that's part of the assumptions we make. We'll learn about it in another chapter. We generally call the project's life its economic life. And the economic life is based on basically experience. Yeah. If you think about it, Okay? You can think about things that you thought would last for long periods of time. Okay? And then it turns out that something else better comes along and we don't use it anymore. Okay? I mean, that's the whole idea about competition. If you go back and remember, and you guys won't probably, you're too young, but Motorola was the dominant cell phone maker in the world. And they had the coolest phone ever, the Motorola Razr flip phone. Yeah. And man, people bought those like crazy. Yeah. And they had something like 65 to 70% of the market share for cell phones. Yeah. Until what? Until now they have none. Yeah. Why? Someone else came out with a better product. Okay. As soon as the iPhone came out, it started to disappear. Okay. BlackBerry was another one. Okay. BlackBerry started to take some market share, okay, because theirs had a little keypad and you could type on it, and it had the best security. Okay. And guess what? Minus a few government agencies, no one uses a BlackBerry anymore. Okay. So things disappear over time. Okay. So we give things an economic life based upon history. Okay. Sometimes it'll last longer, and that's good. Sometimes it gets cut shorter. That's bad. But we've got to look at, that's why we discount things at an interest rate to account for the risk. Okay. So we look at project A, it's got a 4-year economic life. Project B, Project B costs $400,000. And it has an economic life of 5 years. So now we're comparing a project A that lasts for 4 years to a project B that lasts for 5 years. That's why we don't evaluate these at the end of the life of the project, because both of these projects don't have the same ending year, but they do both start at year 0. So that's why we use net present value, and we evaluate the benefits minus the cost. At year 0. And that gives us the net present value. Okay. What's interesting to see is how sensitive these projects are to changes in our inputs. Now, before I get too far along, let me stop here. I just noticed we're almost out of time. Yeah. But go ahead and work through project 2. You can find the answers. And while you work through project 2 and you find the answers, I want you to start to think about the differences between A and B. Okay. I'll give you the first major difference besides the time year. Okay. The major difference is one costs $250 and one costs $400. Okay. Now you might think, oh, that's important. Okay, it is kind of, but capital isn't really constrained. Okay. That is, people can go out and normally raise capital if you have good ideas pretty easily. Okay. So look at some of the other differences in the cash flows, okay, as you work through these problems. So go ahead and work through these problems and see if you can figure out what these two are. And at the end, I'll show you what the crossover discount rate is. All right. Any other questions? I know we're out of time, but see if you can work through that, and we'll pick it back up on Tuesday. And hopefully I'll have you test graded before then. Yeah. And have a good Easter break, I guess. Any other questions? All right. We'll see you next Tuesday then.